Hello everybody, my name is Gina Chapman and this is my submission for CPSC 2100 problem set 5. Okay, so for this problem set, it's going to be working with a cipher, and I was given a pretty lengthy starter file, so it has all my starter code, so I am just coding certain parts of it. So problem 1 is to build the shift dictionary and apply shift. It says that the message class contains methods that could be used to apply a cipher to a string, either to encrypt or to decrypt a message. In the next two questions, the next two questions you will fill in the methods of the message class according to the specifications in the comments. The methods in the message class already filled in are these right here. So the first method that I'll be filling in is the build shift dict method. This is making a dictionary. Be sure that your dictionary includes both lower and uppercase letters, but that the shifted character for a lowercase letter and its uppercase version are lower and uppercase instances of the same letter. What this means is that if the original letter is A and its shifted value is C, the letter A should shift to the letter capital A should shift to the letter capital C. So we're going to do this first, and then I will go down here to part 2 of this first problem. So this is where I start. Let me delete this. So we're going to start by creating the dictionary, and it's just going to be empty. And then we're going to use the import string up here to get the uppercase and lowercase letters. So we're going to go upper, we're going to do lowercase, hold on, lowercase equals string ASCII, and then lowercase. So that gets the lowercase letters, and then uppercase is going to be the exact same thing, except it's going to be uppercase. So there's that. So now it's time to populate the dictionary for the lowercase letters. So we're going to do a for I in the range, the length of the lowercase. We are going to, so shifted index is going to be I plus shift divided by, or not divided by, but mod 26, which is the number of letters in the alphabet. This is going to calculate the new index after a shift, and then we're going to add the new shifted, the new letter after the shift into the dictionary. So that should do that. And now we're going to do the same thing for the uppercase. So I'm just going to copy this. So now all I have to do is return that. So there's that for that function. It says that fill in the apply shift method. Remember, spaces and punctuation should not be changed with a cipher. So this applies a Caesar cipher to the message text with input shift, creates a new string that is this, and returns the message text. So it does all this stuff. So what we're going to start with is we're going to call in, not this. So we're going to call in the, what's this? Okay, so we're going to call in this method we just did up here. I'm going to need that. This gets the shift dictionary using the given shift. And now we're going to create a list called shifted message, and we're going to make it empty for the moment. This is going to be storing these shifted characters. So now we're going to do a for loop. So for character in self dot message text, this is going to loop through each character of the message. Okay, I need to hold on. I need to do so if the character in the dictionary, if it's in that, then yeah, we're gonna add the shifted character to the list up here. Okay, shift. There. Else. So if it's just punctuation, so this is basically it. If it's punctuation, then it's going to append the original character and add it to the list. And now we're just going to return join. This is going to put the shifted message in quotes, I think. Yeah, it's going to put shifted message in quotes. Where are we at? Oh no, where'd I go? Okay. Okay, so that is the end of that method and the end of problem set, at the end of problem 1. It says for this problem, the graders will use our implementation of the message class. So it's a subclass of message, and it has methods to encode a string using a specified shift value. Our class will always create an encoded version of the message and will have methods for changing the encoding. So the methods I should fill in are going to be this one, so which is going to be using the parent class constructor to make my code more concise. The getter method, this getter method as well, which should just return a copy. This getter method, and then this method, the change shift method, and then if any other methods that I think should be in there. So we're gonna call that superclass, right? This is calling the parent class that we just did. Hold on. So we're calling that, and then we're going to we're storing the shift value, and then we're going to see. Nope, that's not what you need. We're going to we're creating the shift dictionary from the build shift dictionary method that we did earlier. Then we're going to encrypt the message text. Nope, that's not how you spell that. U-C-R-Y-P-T-E-D. And we're going to, this is going to apply the shift. This is going to use the apply shift method that we just did in the previous class as well. Okay. And now we're going to, this is going to be it for this first method. It's really simple. Since I'm calling the parent constructor, I don't have to have a lot of code here. So yeah. Next we're on to this. So it's just going to safely access the self.shift from outside of the class. Okay, so seriously just going to just click return self.shift, and that's it. And then on to this one as well. This is going to create a copy, so it's going to be a little bit different than, oh, I'll just try pointing, like you can see me pointing. It's going to be a little bit different than this up here. So we're just going to return, see if I can spell return right. Just going to return self.encrypting, and then we're just going to do dot copy, so it's returning a copy, and then it adds the little parentheses there. Okay, and then that is that for that method. Again, very simple. And then next here, to get the message text encrypted, it's just going to be like it was with the shift. It's going to be this, and then yeah, that's it. That's all it's doing. So these three are pretty simple. And this next one is a little bit more code, but not really too much. So this changes self shift and updates other attributes. So it doesn't, and it also doesn't return anything. So we're gonna go self shift equals shift, which is, this is updating the shift value. And then self dot encrypting ticked equals self dot build. So this is just updating the dictionary again. And then time to update the encrypting message. Update the encrypted message. We're calling apply shift again. So that's that for that method. Just simple. This whole second class is pretty simple code wise. So now I think we can move on to problem 3. So we're using both of these classes. So given, let's see, fill in the methods in this class according to the specifications. The methods that I should fill in are this one and this one. It also has, there's also a helper function for this, and I'll show you where that is. Should be up here. So this is the helper function for that second part. So now we're here. So this first function initializes a ciphertext message object, and it has these two attributes. So let's get started with that. Okay, so we're gonna again call on the parent class. We're gonna call the parent class constructor again, like we did in the previous class, and that's literally it for this first little method right here. And then next we're on to a decrypt message. This is start here. This is actually going to be doing the decrypting. But yeah. So, and here's all of the stuff for it. So we're starting with the max valid words, which is going to be 0, which is, this is going to be the counter of the maximum valid words. So yeah, that's just starting at 0 because, you know, it hasn't started yet. Best shift is also going to equal 0. We're just initializing those variables. And then the decrypted message is going to be just that. Just, yeah, just to start off everything. And then next we're starting a for loop. So for the shift in range 26, so it tries each shift from 0 to 25. Shifted text equals self dot apply shift. So we're calling that function we did a long time ago. Then we're going to do 26 minus shift. So this decrypts the message with the current shift. Yeah, so next we're on to the variable words. So it's going to be shifted text dot split. So this splits the shifted text into words. Yep. Then next is valid word count, which is gonna count the valid words. So this is gonna be sum1 for word in words if is word self valid words. So basically, if it adds 1 for each word that's in words, if is a word. So if it's a word, it adds 1. And then we're gonna do a little if statement in this for loop. So if valid word count is greater than max valid words, so this checks to see if the shift has more valid words, and max valid words equals valid word count. So let's just update this max valid words. And then we're going to update the shift value. And then again, update the decrypted message. Okay, then I'm just going to return best shift and decrypted message. So that is it for this. So I should be able, if I hit run, all this code should run, and so it's loading all the words from this file right here, and the expected output is this. The actual output is this, which is good. From this, so this is encrypting hello into this, and this is decrypting. So it should be hello. The actual output is hello. So yeah, that works as intended. So on to the next section is to decrypt a story from this story text file. So yeah, that's what I'm doing. So I have to create my own functions and methods and all that. So let's get started with that. And it's not too much. I'm just gonna stick it under these and just mark that. So we're going to define a function called decrypt. So we're starting a function decrypt story. So encrypted story, we need to get that. We're just going to get story string, which I think was one of the helper methods. I'm pretty sure up in the top. Let me see. Yeah, it's up here. So it's gonna import that text file all the way down here. And then we're going to cipher text equals cipher text message. And we're just gonna put in encrypted story. So this creates a cipher. This creates an object with the encrypted story, and then best shift and decrypted story equals ciphertext decrypt message. So this is what's decrypting the story. It's using all this stuff that we've done before, and we're just calling it to just do this story right here. And then finally, let me just put this. We're just going to return these two variables. Yeah, we'll just return these two variables, and then we can run them. So we've got to call best shift story text, which is going to equal this, and then we can print best shift, which is going to be. So we can print best shift and print the decrypted story as well. And this should be it as far as the code goes. So let's see. Okay. Those two are the same. There's the best shift, a decrypted story. Yep, that looks correct. So yeah, that is it for this problem set. If you have any questions or comments or concerns, please let me know in the comments, and I will try to answer them when I can. Alright, bye!